So, welcome to lecture 4, and in this lecture, we'll begin with this idea of uh, where we left in this part 3, which is uh, abstract object and this physical object. We saw that point has no parts. That was the definition given by Euclid in his book 1. So, if a point has no parts, then does it even exist? Because and how come a point which has no parts, no length, no breadth, no height, and when they are put together it creates a length, the effect of length, which is a line is what? Line is just collection of points. So how does something which has no length, no breadth, no height, when they are collected together they contribute to the length? This is itself a paradox, isn't it? And so we ask, is this a real object? Point, line, triangle, are these real objects? Because they are all made up of points which has no parts. It means, no parts means what? It is not matter, it is not made up of atoms. You cannot break it down further. Not even that. By parts does not even mean the matter. It means you cannot break it further. You know? A point has no length, no breadth, no height. So it doesn't exist. Where does it exist? I mean, a triangle does not exist anywhere. So the point, so the line, because everything is made up of points. Right? So it's a very deep question. It's a very deep question. Now, so does they have the physical existence in this physical universe? No, because it's an idea. It's an idea, it's not matter. You cannot touch it, you cannot measure its weight, you cannot find electrons, protons, neutrons in the line. There is nothing like that there. They are beyond this reality. This concept is beyond physical universe. But then we ask a very important question, which is, then how does something which has no size whatsoever, it's completely surface area, there is no surface area, there is no volume, but how does something sizeless creates this effect of size, which is line or surface area or volume? That's a very paradoxical things, it appears. Because it should not have that. Something that does not have size, how come sizeless thing put together creates a size? That's like magic. But then that is not, but we cannot question it because that's the assumption. That's the assumption we make. You cannot investigate further into this problem. You cannot go beyond the point. Point is the final thing. Point is the basic element, basic atom that build the whole geometry out of it. We can build the whole geometry out of it. Right? So yes, abstract object, point, line, triangles, rectangles, circle, these are the abstract objects. They don't have existence in this real world. Physical object is like solid, liquid, gas, carbon, nitrogen, oxygen, stone, table, pen, paper. These are the physical objects. They have the existence in this real world. You cannot attach physical observables to the mathematical object. Consider a circle. Does circle have energy? Does it have momentum? No, it does not have that. There is no physical observable attached to it, except there are, of course, for example, length, area, volume, right? These are the physical observables, they are attached to them. But then that doesn't, see, I don't want to go deep into it, but because that is a different topic. But anyway, what I'm trying to say here is that even though we have physical variables attached to them, it's abstract, it's a very abstract concept. Length is a property of a line. Length is a physical observable, you can measure it. So you can measure the length of a line, But then line is not like a photon, like an electron. Line is an idea, For example, chess, the rules of chess. Chess exist. There is a chessboard. There are those object pawns in the chess. They exist. But then where is the rule? Where does the rule exist? They exist in our head. They are ideas, right? You don't find them in real world floating in the space-time. No, those ideas do not float around here. They are rules. They are codes. So physical object and abstract object, they are completely different concepts. And nobody has ever been able to solve this problem. Some says, like Platonic idea, Platonic thought that mathematical objects do exist in different realm, mathematical world, some different space-time. There are other formalism. Hilbert thought it's just an idea, we invent it, we make the rules, it's up to us. So we invent those mathematics. Some says, we discover the mathematics. These are the very different debate going on in mathematics. But that is not the problem. We are interested in different things. So let's go here and let's build the proof of this triangle that we were trying to do and see where does it leads. That is the legitimate step here. So we saw, given a triangle, with vertices A, B, C, angle, let's say alpha, beta and gamma, we had to prove alpha, angle beta, angle gamma is 180 degree. And we said the step 1 to prove is draw a parallel line. Now how do we draw a parallel line? We have 3 options here. Why we have 3 options here? Because what is the parallel line postulate says? There is the idea, how can we draw a parallel line if given a condition? What is the condition given here? We have a line given and a point given. Here is line and a point. Or another option, here is a line and another point. Or here is a line and another point. Right? And it does not matter which one you choose. Right? Because why it should matter? It does not make any sense. All are same things. We can choose here and draw parallel line here. That will be parallel to this BC. Or we can choose this point and this line and draw parallel line here. That will be parallel to this one. Or you can choose this point and draw parallel line to this. So we get this kind. This is parallel to this. Right? We can choose any one of these conditions and we can prove this theorem. So the first step is to draw the parallel line. Given a line and a point, Euclid said you can draw exactly one parallel line. And we saw this fact fact contains another fact, which is that through a point infinite line can pass. And then we saw this fact contains another fact, which is line is breadthless length. And from there we got the idea of point. What is point, right? So we saw fact 1, fact 2 leads to fact 3. Fact, let's say 4 leads to fact 3. This leads to fact 2. This leads to fact 1. Fact 4 was what? Given a line and a point, you can draw a parallel line. This fact, if you backtrack it, we got the idea that through a point infinite line can pass, which verifies from this fact. This shows that for this to be true, there must exist breadthless length, which is fact 3, which is line. There must exist line, and there must exist line. And for this fact to be true, we saw this is made up of point. So we through this backtracking, this postulate gives infinite line can pass through this point. Then we got this idea of breadthless length, and from this we got the idea of point. So these are the 4 facts connected here like this, and we backtrack it. So we saw that this simple statement contains all these 3, right? Now let's prove this. How does it goes? So here we have a triangle. Let's name it. Here is A, B, C. Here is angle alpha, beta, gamma. What is the step 1? Step 1 is given a line and a point, which is given a line BC and a point A, we can draw a parallel line from it. So this is the first. So let's say this is the parallel line. Now, so this is the axiom. I think postulate or maybe axiom. It's a proposition from the Euclid's books. I don't remember some postulate 34 or 31 maybe. And then it says, and then after doing this, we need the idea of we name this angle A and we name this angle B, some angle, right? And then we use the definition of a straight angle. And definition of a straight angle is that a straight angle makes 180 degree. So this here is the straight angle, this A plus gamma plus B. So we see A plus angle gamma plus angle B is 180 degree. This is the definition from a straight angle. So we use proposition this 34 or 31, I don't know the number exactly, which says given a line and a point you can draw parallel line through to it. Then we use definition of a straight angle. Then we use another proposition which is maybe 31, I don't remember that, or maybe this could be 31 or this could be 34, but it doesn't matter number. So this proposition says there exists this one alternate angle, this equal to this, angle A equal to angle alpha. If this line and this line are two lines are parallel, if these two lines are parallel and we draw a line in this, a line that is passing through this both line, then it says the opposite angle of this line, this and this AB must be equal. That is the postulate of Euclid. So we apply this postulate here. This is 31, and we say A equal to alpha. Similarly goes for this, B equal to beta. Now we use this fact in this equation. In the place of A we substitute alpha, in the place of B we substitute gamma. Not gamma, this beta, I made the mistake. Beta is angle B is equal to angle beta, so this will be beta. And we substitute these two values of A and B in this equation, and we see the equation is, original equation is angle A plus angle B plus angle B equal to 180 degree. Now from here angle A equal to angle alpha, so we angle A equal to angle alpha, this remains unchanged, and angle B is angle beta, so we keep angle beta is equal to this remain unchanged. So see, angle alpha plus angle beta plus angle gamma is 180 degree, and here is angle alpha plus angle beta plus angle gamma equal to 180 degree, and this is what we wanted to prove, right? So we prove this fact using these three principles. But these three principles, if we break down into it, we got so many different principles, which is just through backtracking, right? So this is called backtracking process. Now, so we got the understanding of what is backtracking process in mathematics. So if we write down formally, then we can say let P be a proposition, right? Now this P be a compound proposition. Let's say P be a compound proposition. What is a compound proposition? Compound proposition means something that is made up of more than one statement, more than one proposition. For example, it is raining. This is atomic proposition, one proposition. This is one fact it is saying. But if we say it is raining and my father has went to the market. This is two different things going on. It is raining and means it is a connector. It connects two different statements, which is it is raining and the next statement, my father has gone to market. There are two statements going on, two propositions. So this is called compound statement. Compound statement means a statement that is made up of using connector, which is conjunctive, which is and, but, and so on. So in mathematics, a proposition is what? I don't want to go deep into it. I just want to say what is backtracking, and to define it, I need the definition of proposition. Proposition is proposition P is a statement that can be either true or false. For example, sum of angle of triangle is 180 degree. It is either true or false, right? Given a line and a point, or a line, only one line can pass which is parallel to this. This is either true or false, right? If there are two lines on the surface, either they meet or they do not meet. This is another proposition. It can be true or false. So these are the propositions. So proposition can be true or false. Now we take compound proposition. Compound proposition means, as we already said, it is made up of more than one propositions. So let P be a compound proposition. If it is a compound proposition, then it means it is made up of more than one proposition, P1, P2, P3, right? Now let's define an order in this proposition, a relation. Let's say there exists, this is symbol of there exists. There exists a relation among elements of P. This is P, these are the elements. P1, P2, P3, these are the elements of P, right? I mean, I don't want to go deep into it. This is going to be, I'm already using set theoretic language. I think it is better to stop here, and I will make the whole things formal in the next video maybe. Okay.